The last section of stoichiometry is limiting reactants. If one adds more moles of a substance than are needed for a correct stoichiometric ratio, then one of the reactants will limit the amount of the product produced, and the other reactant will remain in excess. Here's a very simple example of a limiting reactant. Let's say we have 2 blue circles and 1 red square, which will yield a compound that has 2 blue circles and 1 red square. That would be the perfect stoichiometric ratio. Let's take this example. We now have 8 blue circles and 6 red squares. Well, combining the best we can with all the stoichiometric ratio, we've got one molecule formed that takes away 2 blue circles and 1 red square, and then another, and then another, and then another. And notice we have not used all the red squares, but all the blue circles are used. That gives us 2 remaining red squares. So that tells us that the blue circles, which ran out first, are our limiting reactant, and the red squares, which have things left over, are called the excess reactant. So we would say that the red square is in excess. Sometimes we just need to find out which is the limiting reactant, and I'm going to use this example to show you how we figure that out. What is the limiting reactant when 32.0 grams of S8 reacts with 50 grams of Cl2? So our first step is to take the grams of each of the reactants and divide by their molar masses. And we get the number of moles of each one. We have 0.125 moles of S8 and 0.714 moles of Cl2. And that's what it looks like right there. Now some people might think, well, there's less S8 than there is Cl2. It's obviously a limiting reactant. But keep in mind that we need to use 4 times as many moles of Cl2 than we do S8. So what we do is we take both of their moles and we divide them by their coefficients. We take the 0.125 moles of S8 and divide it by 1, and we take the 0.714 moles of Cl2 and divide it by 4. That gives us 0.125 S8 and 0.179 Cl2. These are the two numbers we compare to see which is the limiting reactant. The lower number, or the 0.125, tells us that S8 is our limiting reactant, and the 0.179, being the larger number, tells us it's the reactant in excess. We can use limiting reactants to figure out how much of a product should be produced in a chemical reaction. For example, what mass of S2Cl2 can be made from the amount of moles given in the previous problem? So let's remember something from the previous problem. Remember that we determined that S8 was our limiting reactant. Using this information and knowing that S8 is the limiting reactant, we now know that that will determine the amount of S2Cl2 produced. So I'm going to use the moles of S8 that we had in our reaction, 0.125, and we're going to multiply it by the ratio of 4 moles of S2Cl2 for every 1 mole of S8. And that's going to give us 0.500 moles of S2Cl2 that we should produce. If we take those moles of S2Cl2 and multiply it by its molar mass, we get 67.0 grams of S2Cl2, which should be produced. Notice we did not use the Cl2 amount to figure out how much S2Cl2 was going to be produced, because the S8 will actually run out first before we use all the Cl2.